In this video, we are going to discuss modulus. So if you are one of those students who find modulus difficult, who gets stuck in a question whenever he sees there is a modulus sign in the question, if you can't solve modulus equation in equation, this video is for you. We are going to start with the basics, wherein I will start with the definition, basic graphs, properties, and then I'm going to go deep into problem types, where we will see all kinds of questions that are based on mathematical equations, based on modulus, and we are going to see questions based on inequalities. So if you are one of those students who is struggling in complex problem to even basic problem, you will find this video very interesting, and if you stick till the end, it will reward you with tremendous amount of latitude in terms of solving problems in modulus. So without any further delay, let us start with it. First, we are going to start with the definition. So the definition of a modulus function is, if you have a function fx is equal to modulus of fx. So this is the sign. So these two bars are basically the sign of modulus. It fundamentally means that this will be equal to x when x is greater than equal to 0. It would be equal to minus x when x is smaller than 0. What does this fundamentally mean? This fundamentally means that modulus is a kind of a machine. So this is my modulus machine. Now if I put a positive number like 2 into it, what it is giving is the answer as 2 only. But if I put a negative answer into it, minus 2 into it, then again it gives me the positive answer. So what it fundamentally does is, whatever you input into this function, it makes it non-negative. I am saying non-negative because if you put 0, then it will give me 0. So it would be incorrect to say that it makes everything positive. What it does, it makes everything non-negative. So what modulus will do, it will convert everything into greater than equal to 0. This is important. Now once you understand this, what is happening is, if I observe it further, you can see that when I put 2, the answer was equal to 2. So when you put a positive number into it, you get the answer as a positive, same positive number. So it remains intact. So what happened? It did not change. It is intact. It remains same. But wherein if you put a negative number into it, now something special happens. What happens is, it changes sign. So if I am putting minus 2, I am not getting minus 2 as answer. My answer is minus of minus 2. That becomes 2. So we are writing here 2, but this is what is fundamentally happening, and that is the reason when x was smaller than 0 here, we put that as minus x. So it is not negative. Negative x into a negative value will make it positive. This is what is happening. Now you can observe that we can substitute any real value into it, hence the domain is real numbers. But the answer will always be greater than equal to 0. That is the reason the range is 0 to infinity. Now if I go into a very simple question based on this, third, that is given here. Question says that what will be the value of this expression if x is greater than 0. See, now modulus of x will be equal to x when you are putting a positive value into it. This is what it says. So if you have this, and if I want to simplify modulus of x by x, the answer would be nothing but x by x. That comes out to be 1. Wherein this is third. Wherein if I take question 4th, something else is happening here. So in 4th part, when you are doing it, the same question, but it says that x is smaller than 0. So in this case, when you take the modulus of x value, it becomes nothing but minus x. It is interpreted like this, and we understand because modulus is positive. Since this is negative, it needs to be multiplied by a negative quantity to make it positive. So now if I try and find the value of mod of x by x, the answer comes out to be nothing but minus x by x, which divides and make it 1, minus 1. You can see that just by taking different values of x, same expression can have different values. Now there is a fun fact that there is another function, that is signum x, that you are going to ultimately learn, that is connected with this idea. So signum of x is fundamentally defined as modulus of x by x when x is not equal to 0 and 0 when x is equal to 0. So this we are going to see ultimately, not now, not today, but this is an important fun fact. Now moving forward, you can see that the first thing that we are going to learn is how to interpret a modulus which is given in the question. So you understand in this manner that I can do whatever I want with x minus 2 if this modulus is not here. So the first thing that we are going to learn is how to remove the modulus sign. So removing the modulus sign, we call this as interpretation. Now very interesting thing to understand is, you can assume like there is a puppy, a cute little dog that is sitting with her mother. Now, you can't just go and pick that dog up. The reason is that the mother is sitting there. But if I take the mother away, similarly, if I remove this mod, I can go and play with that dog. So this becomes an important analogy in understanding that most of the times when you have mod in the question, our idea would be to remove the mod somehow. And that process we are going to call as interpretation. Now, how to do that? So let us go back to the definition. This definition said that if you have a modulus or the any kind of function, I will get the same value if I am putting a positive value into it. And I am going to a negative times same function if I am putting a negative value into it. You can see that instead of x, we have written some other function. So when we are interpreting, we will also write that function. So if I am writing x minus 2 modulus, my answer is going to become x minus 2 if x minus 2 is greater than or equal to 0. And my answer will become minus of x minus 2 if the value of x minus 2 is smaller than 0. So if I simplify this, this becomes x minus 2 when x is greater than or equal to 2 and minus of x plus 2 when x is smaller than 2. You can see that in this manner we can interpret anything that is inside the modulus sign. This is another question. I hope you will be able to try it. The answer of this question ultimately comes out to be x plus 2 when x is greater than or equal to minus 2 and minus of x plus 2 when x is smaller than minus 2. Now, if I take a little bit more complicated question, all that will happen is I will have to solve a difficult inequality, but largely the process remains same. So, for example, if there is a quadratic here, so what are we going to do? As I told you in my next step, whatever is inside the mod, just write that quantity intact. But whatever is inside, this will only remain the same when this is greater than or equal to 0. Second part is it will open with a negative sign, that is minus of x square minus 4. And this is going to happen when I put the quantity inside the mod as a negative quantity. Now you can see that the answer is simple. I can write it. How to solve this? For that we will require another concept, that is quadratic inequality, or a larger method known as wavy curve method or method of signs to interpret this. So let me do it. So if I have x square minus 4, I can write this as nothing but x minus 2 into x plus 2. If I want to draw a wavy curve out of this, I am going to put this equal to 0, put this equal to 0, mark it on the number line and then draw a wave that goes like this. So you have positive values where it is above the x-axis and negative then again positive. So now what we are saying is greater than or equal to 0 would mean we will include this point. So if I want to give the answer where it is positive, means the duration where it is above the x-axis, these two durations. So x square minus 4 greater than or equal to 0 would mean your x belongs to this region, that is minus infinity to minus 2, then union 2 to infinity. This is what we will want. Similarly, if I flip it and write the answer for next one, x square minus 4 is smaller than 0. In this scenario, my answer will become between minus 2 and 2 because for these values only it is becoming negative. This is what I have got, and once I have got this, I can go ahead and write my answer. You can see that the values does not change, x square minus 4 minus x square plus 4, but you can see that here the answer changes. So x belongs to minus infinity to minus 2, union 2 to infinity, and in this second case it becomes x belongs to minus 2 to 2. So in this manner, whatever is the function inside the mod, you can always interpret it. What will happen is, if it is a more complex function, then your inequalities will become that much complicated. But if you are comfortable with solving inequality, largely you should not face any issue. Now I hope you will be able to solve this question. Let me write the answer to this question. So this comes out to be x square minus 3x plus 2 when x square minus 3x plus 2 is greater than or equal to 0. That happens when x belongs to minus infinity to 2 union 1 to infinity, and this will become minus of x square minus 3x plus 2 if I am looking into values of x that are between 1 and 2. So I should write 1 here and then 2 here. Hope you were able to understand the core concept behind this after solving this question. So this becomes 1 to 2. Now once you have understood this, let us move to questions involving two different moduluses. So now you can see that from one we have graduated to solving involving two different moduluses. So how to go about this? So there is a technique that is based on few steps. So what are the steps now? So what I am doing is, first I am trying to remove the mod. For that I will have to define my intervals. So the first idea is to understand how to know those intervals. For that, there is a very simple step. Whatever is inside this mod, you put that equal to 0 and get a value of x from there. So x comes out to be equal to 1. Similarly, I can put this part equal to 0, that is x minus 2 equal to 0. Get a value of x from there. In my step 2, what I can do is, I can take my number line, plot these points on this number line. So I have got 1, I have got 2. You can see that as a result, your number line is divided into 3 parts. One are those values of x that are smaller than 1. This will become my case 1. Second are those values for which x lies between 1 and 2. This becomes my case 2. And there would be a case 3 when values of x are greater than 2. This becomes my case 3. Equal to sign you can put either side. It just depends on what you want to exactly do. Now what we are going to do in this scenario is, we are going to take each of these cases and solve them one by one. So let us take the case 1 first. So in my case 1, the values of x are smaller than 1. See, now if you are taking values smaller than 1, what will happen to x minus 1? So if I take values smaller than 1, x minus 1 would be negative. You can check it by putting any value smaller than 1. For example, 0. So 0 minus 1 would be equal to minus 1, that is smaller than 0. So you can see that if you are putting a value smaller than 1, largely speaking x minus 1 becomes negative. And once it has become negative, if there is a modulus sign in front of it, so that would be interpreted as nothing but with a negative sign. Similarly, if you look into the next part, that is x minus 2. Here your x minus 2 again would be smaller than 0. Why? Because you are looking into a value smaller than 1. And now as a result, x minus 2 ka mod will still be open with a negative sign. So now this is very interesting to understand why we are putting a minus sign here, because both of them are smaller than 0. And for modulus, if you put a negative value inside it, in order to make it positive, you will have to put a negative sign over it. Once you have understood this, in this first interval, you will be able to write this as nothing but, the first one will open with a negative sign. So I am writing y will be equal to minus of x minus 1 minus of x minus 2, which ultimately comes out to be minus 2x plus 3. This is what we have got. So once we have this, we will move to the next case, that is case number 2. In case number 2, what we are saying is, what if x lies between 1 and 2? Case 2. X lies between 1 and 2. Now in this specific scenario, what happens is, if I am considering x minus 1, if I put the value of x is 1.5, what will happen to x minus 1? So 1.5 minus 1 will become 0.5. That is largely greater than 0. So this value becomes greater than 0, and if it is greater than 0, what we can do is, we can open the modulus with a positive sign. So in this case, when you want to interpret, you will write this as nothing but, since this is greater than 0, you can write this as nothing but plus x minus 1. Similarly, if I look into the second part, if I look into the value of x minus 2, if you put values now, this would be negative. You can check by putting 1.5 minus 2. So this time, since it is negative, this modulus will now open with a negative sign, because the quantity inside it is negative. Once you have understood this, using this we can figure out the value of y. In this duration, when you are figuring out the value of y, it comes out to be, from the first part, x minus 1, and from the second part, minus of x minus 2, and as a result the answer becomes nothing but 1. This is the second one. If I do this for the third part, let us do it for the third part as well. We are looking for values of x greater than 2. This is my case 3. So in this case, what you can see is, since we are looking into these values, x minus 1 now would be positive, as a result, when you take x minus 1 ka modulus, it would be interpreted now as x minus 1. Similarly, x minus 2 value, if you check, it will also be positive, and hence in this part also would now x minus 2 mod will also be interpreted as nothing but x minus 2. Once you have both of these, you can find the value of y by substituting the values. So first part becomes x minus 1, second becomes x minus 2, and as a result my final answer comes out to be 2x minus 3. So you can see that in these 4 basic steps, you can assume this next step is a grand step 2, and we have done multiple parts into it. In the third step, we will go ahead and write the answer. So if I want to write my answer, you can see that there is not 1 but 3 parts. The answer from the first case, that is minus 2x plus 3. This was the value when you are looking into values of x smaller than 1. Next one was, if I get between the values of x between 1 and 2, we get this value. But if you are looking for values of x greater than 2, the answer comes out to be 2x minus 3. I hope you understand this. This is the most fundamental and important part in this chapter. Now, once you have understood the basics of the chapter, the definition, let us go towards the properties. Now, the first property that we are going to see is interpretation based property. So now, whenever you see a square over x and there is a root sign over it, it won't be interpreted as x but modulus of x. This is very important. Multiple places we are going to see that. What I am trying to tell you is, if you have sine square x and if I put a root sign over it, so what is going to happen? The answer is not sin x but mod of sin x. So whatever is inside this, it does not matter. So if you have f of x ka whole square, if I generalize, if I put a root over it, the answer becomes modulus of fx. This is very important, very important. Do not make this mistake of directly writing the function. Now, once you have understood this, let us move towards the next property, and that is nothing but nature of the function. Now, if somebody says you that if I have minus of x and if I take a modulus over it, the answer is going to be same as the answer of modulus of x. Why it's so? Because if I put the value as minus 2 and if I take a modulus of this, it is also 2, and if I take 2 and if I put a modulus over it, the answer will still be 2. You can see that both of these values are largely same. It is not going to make any difference. Another thing is, when we looked into the modulus, we understood that the value is always greater than or equal to 0. So if somebody is giving you modulus of x is greater than or equal to 1, this is totally possible for some values of x like 2, 3, 4, in fact minus 2 will also satisfy. But if somebody is saying that modulus of x is smaller than or equal to minus 1, this is totally impossible because modulus of x can't be negative. You do not need to solve it, you will directly say that it is impossible or x belongs to null set. Very important thing to understand. Next set is based on addition. Now, what are addition based property? So if I add two x and y inside a modulus, when we are writing x and y, it can also mean two different functions we are writing inside a modulus. Then what is going to be the answer? Let us take an example. So if I take this value as 1, this is 2. If I add them and take a modulus, the answer is going to be 3. And if I take individual moduluses and add, still the answer is going to be 3. Now, let us make this value as minus 1 and this is minus 2. Still, if you do it, this is 3, this is 3. But if I take one of those as positive, like plus 1, and the second one as negative, like minus 2, let us see what happens. Now, this will become 1, this will still remain 3. And then if I make this as negative and the second one is positive, still this will remain 1, the next remains 3. Now, this fundamentally means 3 very important ideas. Let us go over them one by one. If I look into the first idea, what we are saying is, if my x and y are both positive or x and y are both negative, in this scenario, that is case 1 and case 2, in this scenario, x plus y ka mod becomes equal to mod of x plus mod of y. That would mean if this is there, I can conclude this. But let us say if this is given, the second statement, from here I should directly write this can only happen when x into y is greater than or equal to 0. Even 0 will also work. So this is a very important idea, because if they are positive, multiplication would still be positive. If they are negative, multiplication would still be positive. Second important learning out of here is, if my x and y are opposite in sign, so if this is greater than 0, y is smaller than 0, or x is smaller than 0 and y is greater than 0, both of these scenarios, what have we observed is, that is case 3 and 4, if I take mod of x plus mod of y, it is usually less than mod of x plus mod of y. This is what happens. That would mean if this is given, I can write it, but let us say if this is given, I could write that since they are opposite to each other in terms of sign, then multiplication would be negative. This is a very important idea. Third, we can combine both of these and write a generalized statement. See, for any of the scenarios that is possible, if I write x plus y ka modulus, this quantity is always smaller than equal to mod of x plus mod of y. This we have generalized this idea of first and second into the third statement. Now, let us say that we are doing subtraction. Let us see what happens in this case, and this becomes a way how to interpret these ideas. Okay, so this is not just a result per se, but also a way to interpret these kind of scenarios, because they can do multiple things. They can introduce plus minus sign, they can do multiple things in this, and we can make it a very complicated question sometimes. So if you remember how I came up with the ideas, it would be easier for you to interpret as well. So if I now here take the value of x as plus 1, value of y as again plus 2, and if I subtract them, the answer is going to become 1. If I take mod and then subtract, the answer is still 1. If I again write minus 1, minus 2, this subtraction would again become 1, and again this will also become 1. In the third case, if I am writing here minus 1 and plus 2, let us see what happens. Now this will add up and would become 3, this will still be equal to 1. And if I write here plus 1 and then minus 2, this will again become 3 and this will remain 1. So this is a very important idea that you need to understand. Now again, as we did in the last class, we can condense this into 3 very important results. The first result is, and be very careful, there is one more modulus sign here. When we have x and y both positive or x and y both negative, that is the first two cases. You can see that in these two cases, both of these statements were equal. So that would mean in this specific scenarios, I can write mod of x minus y is equal to mod of x minus mod of y. So if this is given, we can write this, or if this statement is given, this could be interpreted in terms of writing x into y is greater than or equal to 0. This is very important. And this is how we are most of the times use this idea to solve modulus equations. Second idea is what happens in the next two cases. What we are saying is, if it is x into or y, these are of opposite signs. So let us write x is greater than 0, y is smaller than 0, or opposite, x is smaller than 0, y is greater than 0. What happens in these two cases is, now the mod part, you can see that x minus y modulus, this becomes greater than mod of x minus mod of y modulus over this. This is very important. We can write it from first step to second step, and from second to third. If this is given, this could be interpreted that both of them are opposite in sign. This is very important. This is how we are going to use this idea when we go towards equation or inequation in solving the questions. Now, as a general, I can write both of these. This is very important. I can write both of these statement as x minus y ka modulus. You can see that this is always greater than or equal to mod of x minus mod of y ka modulus. This becomes a generalized format of what we have generally done. Now here, very important thing to notice is there is a modulus sign here outside. This is very important. This modulus sign is very critical. Why? Because if I remove this, this relations would not be valid. So what we are going to do in that case, my recommendation is don't try and remember everything. Remember that we have a coherent thinking process into place. Use this case based approach, and whatever new question comes, you interpret it yourself and then write the answer. Now let us go to again some simple properties that are based on multiplication division. So if you have multiplication of two numbers, it is equal to the multiplication of their modulus. This is quite simple. So what we are saying is, if there is minus 2 into 3 and if I multiply them, the answer will become 6. Wherein if I have mod of minus 2 into mod of 3, it still comes out to be 6 only. So this is what we are trying to say. In the next one, when we are doing the next one, what we are saying is, if you put modulus inside the mod or outside the mod, it is fine. So what we are saying is, if you have minus 2 raised to the power 3 and then if you put a mod over it, the answer is still going to be 8. And if I have minus 2 ka mod, then if I put a mod over it and then take a cube, the answer is still 8. So it does not changes. That is the reason we can take both of these as equal. The next one is again equally interesting. What is happening is if you have x by y. So what they are saying is, let us take the value of x as minus 2. This value is 3. And if I put a mod over it, the answer is equal to 2 by 3. Wherein if I take mod of minus 2 by mod of 3, the answer is still 2 by 3. Again, very important thing to understand that all of these operations can be done seamlessly. Again, you can pause the video and go over all of these results. I have summarized in the form of a table. It is very useful to remember this table. Now, we have covered the basic properties in this one. In the next one, we are going to look into the basic graphical transformation that we can do in Modulus. We are going to use this transformation in solving more complex questions based on equation and equation. So don't miss the next one. Catch you in the next one. Bye.